So if you're someone like me who likes to open up different electronic gadgets flying around your house and getting scoldings from your parents for that, or if you're someone who likes to make things or is really into electronics, then you found the right place. You definitely must have heard about something called the Arduino. You must have gone through thousands of such projects on Instructables or different places, and you're not able to make any sense out of them because you don't know the basics yet. So today the Nerd channel is going to bring you the basics. Tune right in because we're going to start our journey today for something really good coming ahead. So let's get started. So this weird looking thing right here with so many circuit lines, so many pins and many more such boards. So how are you going to do with this? How are you going to make projects with this? That's what I'm going to show you. But before that, let's take a look onto what does this board have and what you need. So as you can see, we have so many pins lined up here. These are called the digital pins. These are basically 1 and 0 pins. So if you program the Arduino to give power high or power low, they either get on or they get off, giving power to the device depending on the program. Then we have another set of very common pins. These are called the 3.3 volt, the 5 volt, the ground and the V-in pin. So the 3.3 volt pin supplies 3.3 volts as the name shows. Then we have the 5 volt pin right beside it. It supplies 5 volts, and the ground pins. So the ground pins basically to ground your device or to give the negative power, negative of the device too. Remember guys, the 5 volt and 3.3 volt are not always exactly 5 or 3.3 volt. They actually kind of depend on the supply that you're giving to the Arduino. So be very careful of what you are supplying to the Arduino. Okay. Then we have a small LED L. Okay, so this LED is basically what is connected to pin number 13. So and this always stays on whenever the Arduino is on. Then we have the TX and the RX LEDs. These LEDs glow when the Arduino is either transmitting or receiving from the system you are connecting it. And there are several other devices like the ESP device. So this is an ESP device guys. So this basically transmits and receives information to Arduino. This connects to a Wi-Fi. I'm going to show you this project at a later date. This is a work in progress right now. Then we have something called the analog pins right here. The analog pins are named from A0 to A5, and to this you can connect something like the potentiometers and other devices which require analog communication, which are not basically only on and off. Then we have this is the port to which you connect your Arduino to the PC. So this basically uses a printer cable or USB A to USB B cable. Once again, let me show you the cable guys. So on one side you have the normal USB head of the cable, but on the other side you'll have this. So you can just type in Amazon for like a printer cable, or you can type something like USB B. Okay. Then we have this right here. So you can give the power supply to the Arduino using this pin. This is like a very common pin. You can find it in the stores. A power adapter like 9 volts adapter or something can be connected to the Arduino. An Arduino basically requires around 12 volts depending on the components that you have connected to it. Be very careful. The current has the voltage has to be DC voltage. Then the output voltage by the Arduino depends on the input voltage that you're giving to the Arduino. Giving lesser voltage and taking more voltage out of the Arduino can potentially burn the device guys. So be very careful about it. Now I'll show you a very simple example that will help you understand how the Arduino works. So now let's get started with a simple example so that you'll understand how the Arduino works. So the components we're going to need for this is obviously the Arduino board. Along with that, we need a breadboard for making things simple for us. Then we need something called the jumper cables, which are really helpful. I recommend you buying. These sell pretty cheap on Amazon, so I'm going to put a link down in the description So you can see, then we also need an LED obviously and a resistance to protect the LED. I'm using 1000 ohms or 1k. So now how does the connections work? So before that, let me just explain how does this breadboard work. So the breadboard is basically a simple prototyping area, so where you can try out different connections without actually have to making them permanent. So you can, it's a plug in and plug out thing. So now how does this work? So all the horizontal ones are independent of each other. They are not connected to each other electrically. All the vertical ones like F, G, H, I, J or A, B, C, D, E are connected to each other. But A, B, C, D, E is not connected to F, G, H, I, J because there's a break line in between. Then plus and minus lines on both the sides are little different. Here these are connected in the horizontal way instead of the vertical. So all of the plus and all of the minus ones are connected. Yeah, remember plus and minus are obviously insulated from each other. Also, unlike some larger breadboards, there's no break in between. So your breadboard might have a break in between. So check that out before you go ahead. Then so let's get started. So what is the basic procedure is, let's put the longer LED line, the wire. This is the positive, obviously. So the longer one's the positive. So let's just put the longer one here and the one beside it like that. So it's just gonna go in there like that. That's perfect. Now we want the resistance. So just pick up the resistance and put it up right beside it. So right in the same vertical line, because all of them are connected. You want to connect the resistance to the LED. So put it in the same vertical line. And then I prefer putting it in the plus line just for understanding what you're doing. Right now it doesn't seem much, but when you get into complicated structures, it's really helpful to color code your wires or use these plus and minus lanes for proper use and to avoid any confusion in the later part. Then just take one of the wires. Here all of them are connected, so it doesn't matter where you plug it. Just take it and put it deep here. Then now let's choose a pin. So here we're going to use the digital pins. I've told you the digital pins are the only ones that really matter right now. So let's just choose a pin. Let's just go for 2 right now. Believe me, you can do any pin, doesn't really matter, 1 to 13, but it's on your wish. 2 is my lucky number anyway. Then ground. So all the grounds on the Arduino are connected with each other. So just put it into any ground, it doesn't really matter, and put it onto the other side of the LED. Okay, so now that we're done with the connections, remember the connections seem too simple right now, but in the future there may be some real complications with other type of complicated projects we'll be doing soon. Now let's just connect this to the laptop and let's just program. So now basically let's jump right into the programming. Remember, you need a USB A to USB B USB cable, so you'll be able to plug it right in here and then use it with your Arduino. Sorry, I mean the laptop. So let's get straight into this.
So now that we're done with the connections part, let's get started with the programming part. Believe it or not guys, blinking an LED with the Arduino is definitely what you want to learn. Though it sounds stupid, it's really fun. So let's just do it now. I'm opening the software called the Arduino IDE right now. The Arduino IDE is basically where you write all the programs. So there we go and click the new sketch. The new sketch pops open and you can see there are two different things. One's the void setup and the other one's the void loop. The void setup is where your code runs once, whereas the void loop is where your code runs twice. Not twice, I mean it just loops around again and again. When say for example you put a code, so you want to define your LED pin. Remember guys, we have put the LED in pin number 2, so we have to first define the LED that it is in pin number 2. So let's just do it. So we say int LED, whatever you want to name it, let's name it LED here for now. LED equal to 2. Remember, every line ends with a semicolon. Then in the void setup, this is where the initial setup goes. Now we want to set the pin number 2 as an output pin, such that the pin number 2 gives the output to the LED, not take input from it. So we use the function called the pin mod. the pin mod function, where is basically where you set the mode of the pin. So now let's just start with the pin mod function. There are two possible modes, one's output, one's input. So here we're gonna use the pin mod output. So pin capital M O D E brackets open, and you're gonna type LED comma output. That's done there. Then every line, remember, ends with a semicolon. Then in the loop, now since the pin mod is set to output, now you want to program it such a way that whenever you want, you give the power. So for that we use a function called the digital write. So this is something called digitally writing the pin number 2. Now digital write function basically tells what the pin to do. So here we write digital write LED comma high, where high basically means on. Okay, so there are two possible ways here, one's high and the other one's low. Now you want to type now you just want to blink the LED, you don't want it to stay on forever. So that you do something like you use the delay function. So remember, the delay function has units in milliseconds, not in seconds. So whatever you're gonna type in here is gonna be milliseconds. So I'm gonna take 200 milliseconds, and then we're gonna switch it off at that point. So we're gonna digitally write it again such that the LED goes off this time. So LED comma low. Now after you have written that part out, here you can see that we have written our program, and then we click upload. There are two ways. You can just verify and compile for further editing, or you can upload, where the IDE compiles the code and then uploads it. If it finds any mistake, it prompts you to correct them. Now let's just click the upload button so that the program starts to upload. Remember, before doing that, connect your Arduino to the board and be very sure that you have connected it to the correct COM port. So in the tools you can see we have the port, and here I can see only one option, COM3. So connect to the proper pin, select the proper board, and then click the upload button. Once you click the upload button, it's gonna ask you to save it so that you never lose your codes. So just save it, and it saves them in a standard place called libraries, and then it's just gonna get uploaded. That's as simple as it is.
So now the upload is done, and you can see the LED blinking right down here. Trust me guys, this is only the start. You're gonna have more fun projects in the coming weeks. And yeah, do not forget to like, share and subscribe, because you definitely don't want to miss these getting started videos by the Nerd channel. So see you later guys, and yeah, never forget to click the bell icon. You definitely don't want to miss our next video. Meet you there.